I wanted to go over what we had talked about today in algebra. We did take some notes today, so if you were absent, you can get caught up. We talked about the notes for today were on solving equations, and this is the first day that we're doing this, so we're going to start pretty easy. Let's see if I can get a good pencil here. Here we go. Okay. So I'm going to share my document camera and we're just going to go through the notes similar to what we did in class today, but maybe not exactly word for word the same. Okay. So let's see what we've got here. So let's write notes, solving equations. And we talked about different properties. So we're going to use using inverse properties and properties of equality. Okay, inverse properties and properties of equality. So let's take a look at the inverse properties. Inverse properties are used to undo operations. Remember, you can pause this if I'm going too fast. Inverse properties are used to undo operations. And the operations we're talking about mainly are add, subtract, multiply, and divide. So if I have to add, the property, the inverse of addition is subtract. And if I have to subtract, then the inverse of that is add. Those are inverses of each other. Same with the other two, multiply and divide are inverses. Okay, so we use one or the other to undo the other. Okay, we'll go through some examples so this makes a little bit more sense. The properties of equality basically means that whatever I do to one side of the equation, I have to do to the other side of the equation in order to maintain that equality. This is kind of informal language, but whatever you do to one side of an equation, you must do to the other side to maintain the equality. Okay, so let's take an example, example 1. And this was the example that I gave in class. Now the examples today are very simple. Some of them you could probably even do in your head, but I want to start this process of showing how we're undoing the equation so that when it gets more complicated and you can't do it in your head, you'll know what to do to figure out the answer. Okay, so this is our equation. I am adding 8 to x, and so what I want to do is figure out what the inverse of adding is, and it's subtracting. So I'm going to subtract 8, but I'm going to subtract it from both sides. And when I say sides, I mean sides of the equality. That equality is like where the balance would be in your equation. If you had a teeter-totter, that would be where the fulcrum is. And so this side equals that side. So if I subtract 8 from this side, I have to subtract 8 from this side. And the reason why I subtracted 8 was because I'm trying to get that variable by itself. Okay, that's the object of solving the equation. We want to figure out what the variable equals. Okay, so that goes to 0. The left-hand side goes to 0 here, and so I'm left with just x equals, and then I have to figure out what this is. 5 minus 8 is -3. And this is my solution. So here was my equation. Here was the inverse property of equality. So inverse and property of equality. Okay, and then here's my solution. So your solution means that if you were to put -3 back up in here in the original equation, it should make this statement true. -3 plus 8 equals 5, and then it does. So that I know that I have the right solution. All right, let's try another example. Oops, this is example 2. I think this was the example I gave in class today. 3x equals 45. So 3x means 3 times x, and so I want the inverse of multiply, which is divide. And this is the way we write divide when we're solving equations. We use that bar, the division bar. So I'm going to divide that side by 3, and so then I have to divide the other side by 3. You're welcome to keep drawing a line down here, but you don't have to. It's completely your preference. So then on this side I have 3 divided by 3, which is 1x, equals 45 divided by 3, which is 15. 1x and x, that's exactly the same thing we want to find. So that's our answer. And you can check by plugging in 15 up here. 3 times 15, does that equal 45? Yes, it does. All right, let's try example 3. This was the example I gave in number 3 in class. Let's see if I can bring this up a little higher so you can center it a little bit better. Okay, so we are adding -15 to y. And so what we want to do is subtract -15 from y, from this side. And I want to subtract -15 from this side. So adding a -15 and subtracting a -15, that makes those cancel each other out, which gives me y equals 10 minus a -15 is the same as adding 15. Minus a negative means adding, and so I get 25. And you can check, is -15 plus 25 equal to 10? Yes, it is. All right, let's squeeze in example 4 here. This is what we did in class. X divided by 6 equals 12. So here I'm dividing by 6, so the inverse operation would be multiply by 6. I'm going to multiply by 6 both sides. And so now I'm going to simplify both sides. 6 divided by 6, that goes to 1. 1x is the same as x. And 12 times 6 is 72. And that is my answer. You don't have to put the 1 in front of the x. You can, it doesn't matter. Typically we don't, but it's okay if you do. Okay, so then this is it. The assignment is in your Teams folder. It's homework 7. It is a CUDA worksheet. You need to only do the evens. So let me write that down. So it's homework 7. Look in Teams. It's solving one-step equations. And you only have to do the evens. Okay, so that's it for today. I'll talk to you tomorrow.